In this video, we are going to discuss about some important problems based on screw jack. Question is, a load 50 kN is raised by means of a screw jack. The mean diameter of the square threaded screw is 42 mm and the pitch is 10 mm. The force of 120 Newton is applied at the end of the lever to raise the load. Determine the length of the lever to be used and the mechanical advantage obtained. Is the screw self-locking? Take mu equal to 0.12. Before going to discuss about the sum, we need to explain every individual specifications. The load 50 kN is W, that should be lifted. The mean diameter of the square threaded screw, mean diameter symbol is dm, so dm is 42 mm. Then pitch small p 10 mm. Then force or effort applied at the end of the lever, that is F equal to 120 Newton. Coefficient of friction between the contacting surfaces is 0.12. Now we need to find out the length of the lever and the mechanical advantage. Third one, assumption, is the screw is self-locking or not. So first one, length of the lever. If you want to find out the length of the lever, we need to find out the torque produced on the lever. So torque equal to force into perpendicular length, applied force and its perpendicular length, where we are going to apply the load. So we need to find out the torque first. Here torque find out by two method, or it consider two assumption. One is to raise the load, another one is to lower the load. We know very well, to raise the load formula is mg into dm by 2 into tan alpha plus phi. So torque equal to W into tan alpha plus phi into R. Here mg converted into W, the dm by 2 converted into R. So W equal to tan into alpha plus phi into R. So we need to find out the torque. We need to find out alpha and phi value. So we can go for another two formulas. Tan alpha equal to pitch by phi dm, tan phi equal to mu. Pitch value, mean diameter of the screw, coefficient of friction are given in the question. So we may easily find out tan alpha and tan phi. So from the tan alpha formula, by substituting all the values, we may get alpha equal to 3.64. Then tan phi equal to mu, so phi value also can find out from the formula. Substitute the alpha and phi value in the main formula to find out the torque required to raise the load. Then from the formula, we may easily find out length required. So torque value is known value, the force is 120 Newton. So by substituting this value, we will find out the length required to lift the load, 518.7 mm. Second, mechanical advantage. Mechanical advantage is the ratio of output to input. Here output is the maximum amount of weight to be lifted. Input is minimum amount of effort to be required to apply the end of the lever. So W is 15 kN, F 120 Newton. By applying this value, we may get mechanical advantage is 125. Then third one, we need to find out the screw. Given screw is self-locking or not. Given screw is it having efficiency more than 50 mean it does not have the self-locking purpose. Less than 50 mean it belongs to self-locking. So we need to find out the efficiency. So efficiency formula also explained in the previous slide. The efficiency is tan alpha by tan alpha plus phi. So efficiency tan alpha by tan alpha plus pi. Alpha and phi value is known value 3.64 and 6.84. Substitute the values here, we may get efficiency is 38.4%. It is less than 50%. So the given screw is self-locking.